Hi guys, welcome to the Art of Server. So in today's video, I'm going to show you how to analyze the log files of a Linux system when you're trying to troubleshoot your LSI HBA controller. So recently I had a customer who was having some difficulty with his controller, well actually his system in general, and he asked me for some help because he had bought the HBA from my store, and I asked him to send me the log files from his system so that I could analyze it. And I believe he was using TrueNAS Scale, which is based on Linux. So today's video basically applies to any operating system that is based on Linux. It's basically going to be the same procedure. This will not apply if you are using free BSD based operating systems like the old traditional TrueNAS or FreeNAS or Windows operating systems, because the log file entries are completely different. So this is Linux only, so keep that in mind. So if you are running Unraid, you are running TrueNAS Scale, or CentOS or any other kind of Linux distribution, today's video will definitely help you out when and if you are ever having problems with your LSI HBA controller. All right, so the gentleman who was having problems sent me his log files, and I did some analysis on it, and I want to show you guys today how to do that on your own in case you're having problems as well. All right, so but first of all, I want to show you how to extract the information out of the log files that will be pertinent to troubleshooting your LSI HBA controller. So the customer who sent me their log file sent me this file called diagnostic.txt. We'll just take a really brief look at this right now. So you'll see there's a bunch of messages here, and obviously you can see a bunch of error messages, and so we'll talk about that more in a little bit. But the messages that are in this particular file are all related to storage. And the general log file on your Linux system is going to, of course, encompass all sorts of other things that are other activities that are going on in your system. And so one of the first things I always ask people to do is to run a command that will filter out all the messages that are relevant and pertinent to troubleshooting an LSI controller, SAS controller. So I want to show you how to do that first, although this file is already kind of post that step. But if you guys are doing this from scratch, you're going to need to know that process. So over here on the right side terminal, I'm going to gain root access so that I can access the log file. And in most systems, the log file you're going to look for is the var log messages file. So this is this file right here. And if you look in this file, there's all sorts of messages coming from all the services and different things that might be running on your system. And this is actually my workstation, my HP Z840. And I also use ZFS here, and I have an LSI controller on this thing, so it's kind of a perfect example of this. All right, so what I would do to get the messages that are pertinent to troubleshooting the storage subsystem is this. So I do a grep dash capital E, and there's a very specific pattern I'm going to look for, and you guys might have seen this because I kind of do this. This is a routine thing I do whenever I'm troubleshooting Linux systems, storage subsystems. So I look for MPT, and we're going to look for MPT 2 and 3 because the version of the driver depends on the controller you're using, but in recent Linux kernels, the MPT2 SAS driver got merged into the MPT3 SAS driver, so now you see both messages from the same driver. So anyway, we're going to capture all of that. So we're going to capture both MPT2 SAS and MPT3 SAS messages. And I'm also going to want to look for, I'll do a space, and that space is deliberate, SCSI, space. Okay, so this is to avoid, the spaces before and after the word SCSI is to avoid some other messages that might happen to have the word SCSI in them. And I'm looking basically just for messages coming out of the SCSI subsystem. All right, and then again, we're going to look at the block device subsystem as well. So I'm going to have a space SD space, and then that'll end my pattern that I'm looking for. Okay, so basically I apply this filter to var log messages, and if I just run this right now, you'll see, boom, I've extracted all the messages pertinent to troubleshooting the storage subsystem. So basically, just to kind of review what I'm doing here, MPT3 and MPT2 SAS is basically the driver level messages. So this is the driver module that talks to the LSI controller. Now, if you're not using an LSI controller, then this would not be what you'd want to do because this MPT2 and 3 SAS is specific to the LSI drivers. If you're using an Adaptec controller or a HP Smart Array controller or some other type of controller, you're going to want to figure out what the name of the driver is and search for that keyword instead of the MPT2 3 SAS that I have right now. This is, again, specific to LSI controllers. The next thing I'm looking for is one layer up from the driver is the SCSI subsystem. So that is kind of the low-level communication subsystem that talks to these SCSI devices. And there are different types of storage, but at the operating system level, basically you see a block device, and that's the next layer up, and that's what we're looking for here in the SD subsystem. So that's where we start looking at the storage not as a bunch of SCSI commands communicating, but as actual block devices that you can reference by logical block addressing and stuff like that. Okay, so if you extract the messages, these three types of messages, you basically extract pretty much all the messages that are pertinent to troubleshooting the storage subsystem. And as you can kind of guess, these are kind of like layers in a technology stack. The driver would be probably the lowest layer. Messages here, or especially error messages at this level, are typically indicative of a hardware problem because the driver is having problems controlling and communicating with the hardware, or it could be a software bug, and that's also a possibility in the driver code itself. The SCSI layer is typically so that's one level up. So if you don't see any problems at the driver level, most of the time that means that your controller hardware is good, and so you don't have to worry about that. The next layer up is the SCSI layer, and this is where we're actually communicating to the storage devices. If you see problems at this layer, oftentimes it could be indicative of a storage drive problem. So at the next layer is the block device layer, and this is where the storage is really interfacing with the operating system, right? So from the user standpoint, you see the storage devices as block devices that then you can put a file system on top of and organize your data on that storage. If you have a problem, typically at the very lower levels, say at the driver level, you're going to see that you're going to see that problems there will propagate all the way up. You're going to start, if you see the problems at the driver level, you're probably going to see some messages coming from the SCSI layer and also from the block device layer. Okay, if you have a higher level problem, you might not see problems at the driver level, but you might see it at the SCSI layer or block device layer. So that's why these messages are helpful. It helps you kind of isolate where the problem might be. Okay, so anyway, that's how you would extract those messages. And normally, when I'm helping a customer out, I tell them to run this command and then redirect the output of that into a log file. So sometimes I call it the var temp diagnostics.txt, and then I ask them to send me that file, and then I can kind of review it and try to identify and help the customer out and trying to figure out what's going on with the system. Okay, so now that you know how to get that, let's look at an example. My system is running fine, so the log messages here are not particularly interesting. It's basically just the usual activity of a normal healthy system, and that's not as interesting. So let me clear that screen, but we will look at this one here. So let me full screen that. So we're going to look at this one here. Okay, So the first thing we notice is that there's a whole bunch of error messages. Let me try to highlight a few things here so we can kind of just take a real quick look at it. Let me just highlight some messages here. Okay, so we're seeing some command timeouts basically. So you can see the CDB says read 16, so these are 16-byte CDBs running a read command basically. And you're seeing that the result is failed, and it's because of a timeout. And so you'll see that the command age is 30 seconds, and the timeout setting for this particular task is 30,000 milliseconds. So that's where the 30-second comes from. And so basically a command was sent out and got no response. And so eventually it's timed out and we have a failed condition. So, and this is happening on this drive SDE, which has a target of 0040, as you can see right here. It's assigned the drive letter SDE. Yeah, so we're having some problems, and it eventually, when it times out, it tries to abort the task, and so that's not good. And we're seeing this happen over and over. So far this is happening on drive SDE, and looks like a power on or device reset occurred. Okay, so now looking at the timestamp, this looks like all this stuff happened around the same time. And then we have log messages that are, I think, what is that? That's probably like several hours later. So perhaps the system was rebooted or something like that. I'm not sure exactly. But we're seeing some read problems. And then upon reboot or something like that, it looks like we're seeing problems again on drive SDF this time. And so this is target 0050. And this time we're seeing write errors. So there's a write command right here that's timing out again. So obviously, just first glance at the beginning of these log messages, this person's obviously having some problems on multiple drives here on both SDE and SDF. So let's just kind of scroll through a little bit, and I'll show you how I'm going to narrow this down so that we can actually start like a more deep dive analysis of what's actually going on in the storage subsystem. All right, so it looks like, again, all sorts of bad things happening there around the 425 time frame. Then looks like we don't have storage messages until 834 here. And here we see the driver, the MPT3 SAS driver, announcing itself and its version that it's, the version that it is and that it loaded. So I'm guessing that this system was rebooted and the driver was reloaded and stuff like that. So here we see the driver basically kind of initializing, setting itself up. And you'll see the MPT2 SAS underscore CM0. So that's an instance of a driver. So if you have multiple drivers in here, you will see multiple instances of a driver, each one controlling each of those controllers. And so CM0 would be the first instance. And so we see that it's setting itself up. And like I said, the MPT2 SAS driver got merged into the MPT3 SAS driver. So this is all really, even though it says MPT3 SAS, this is really all the same driver at this point. Okay, so MPT2 tells us this is probably a SAS2 driver controller, and indeed we see right here. Okay, so here it tells us the controller is an LSI SAS 2308, firmware version 20.0.6.0, yada yada. So upon seeing this, the first thing I realized was this is not my controller. This is not a controller from my store, because I've never sold a controller with this particular version of firmware. All the ones, this is not the latest version, it's one sub-revision old, and all the cards that I sell of this chipset are version 20.0.7.0. I went back and asked the individual who sent me this log file about that, and they said yes, they had another controller prior to using mine. That the one that they got received from my store. So anyway, so it seems like this individual had been having some problems already prior to the controller that he acquired from my store, and that's kind of a useful piece of information, because basically later on, as we analyze the log files, we're going to realize that there's probably not a problem with the controller, but the fact that the problem persisted with a different controller with a different firmware version and with the newer controller that he received from my store with the newer firmware version. Kind of tells you that, you know, by changing the controller, the problem didn't go away. So, you know, very likely the controller is not the problem. And we'll kind of get into what we suspect the problem might be. But anyway, okay, so I'm going to kind of just scroll through this really quickly because these are messages that were basically pertaining to this person's system with a controller that was not from me, and I was kind of trying to narrow and hunt down the problem and see if it was related to, you know, the controller that the person had received from me or not. And anyway, so we're not seeing anything here. This is basically the same thing. This is a controller, I think, loading again, so it must have rebooted or something like that. But anyway, I'm just going to scroll through this really fast because we're going to work on extracting more, kind of narrowing down all these messages. So I'm just kind of glancing through them to get a high level overview of what's going on. So again, we're seeing all the same type of failed, timed out commands. And so we're seeing writes and reads also timing out, and this time on drive STB and SDE, SDF. So we're seeing multiple drive problems. So whenever you see a problem like this, so if the problem is isolated to a particular drive, so like as you're, you know, analyzing these log files, that's kind of something that's good to keep in the back of your mind. If you're seeing problems only on a specific drive, then you might want to investigate that specific drive or the connection to that specific drive. If you're seeing a problem that is across the board, then you might want to investigate something that is a common denominator across all those drives that are having problems. So those are just kind of good facts to keep in the back of your head as you're analyzing these log files. So anyway, we're seeing a bunch of errors still with the previous controller that this person had. And okay, so here on August 5th at 1800 hours 37 minutes, there looks like another reboot happens down here. Okay, so here, this instance of the driver is now running version 20.0.7.0. So this is most likely the controller that this person had acquired from my store. So it looks like we don't see that controller from my store in his logs until August 5th. So what I'm going to do here is let's pull out all the messages from August 5th and isolate that. So I'm going to grab for August 5th diagnostics. So let me just take a quick look. Yep, okay, so that looks like, so we'll narrow that down to August 05.txt. All right, so now we can just look at the subset of log messages that are pertinent to this person's current setup with the controller, the new controller that he had acquired from my store. Let's look at this now in a little bit more detail. Let's see how many messages are we looking at here. Yeah, okay, so this is only August 5th. One second here. I think there's more stuff after August 5th, so I want to make sure that we're looking at that as well. Because this individual basically said, hey, the controller seems to work fine at first, and then a few days later starts having problems. And yeah, so on August 11th, we also have some problems here. So that's a few days later. All right, so let's also extract from August 11th, and then I'll append this content to the same file. All right. Okay, so now we have both August 5th and August 11th, and those are all the messages. And so obviously you can see that we have a bunch of those same error messages on August 11th. And we'll get into that a little bit more in detail here. All right, so let's begin the analysis here. So we see the version of the driver being loaded, and we see the first instance of the MPT2 SAS driver being set up here. All right, so whenever you're looking at these driver messages, you want to look for this messages. This message, sending message unit reset. So this is basically kind of the initialization of the driver taking control of the controller and starting to communicate with it. So it always starts with a reset, and basically it kind of starts from scratch. If you see this messages multiple times, that could be an indicator of a problem. So typically, if an LSI control starts to fail, the type of messages you're going to see in the kernel is that you're going to see some sort of fault condition. Usually it'll say IOC fault, and then it'll try to recover itself by resetting the controller. And so you'll see a message like this, and then if the controller does come back online, you'll see a follow-up message that says message unit reset success. All right, so if you see that, then the controller is kind of sort of alive. If you're seeing some faults before this, but in this case, this is the first instance, so we're basically just starting it up. All right, let me just isolate this just a little bit. So we're going to isolate this to MPT2 3 SAS. These are all the driver level messages. Okay, so this is basically the lowest level messages you can get. This is communicating with the hardware. And from here, we basically see that we have this controller, the LSI SAS 2308 with the correct firmware version, all of that good stuff. And we see a sending port enable and then port enable success. So that means the controller is online. And so this is good. This is, basically if you see this, then the driver has successfully started up, starting to control the SAS controller, and everything is good. You'll see that host add, and this is kind of important. There's another message at the SCSI layer that we're going to reference later on with this, and it says here is the SAS address of the controller, and it has 8 files. So there's 8 basically SAS lanes in this controller. All right, so that's some useful information. So now let's look at the entire file again. Okay, so over here, this is kind of important if you're trying to kind of track down things. So you'll notice SCSI host 0, Fusion MPT SAS host. All right, so this is basically saying that the system has assigned SCSI controller 0, if you want to call it a host 0, and it is a Fusion MPT SAS host. So this is Fusion MPT is Broadcom or LSI's technology, or the name of their technology that they use to communicate with their SAS controllers. Basically, this is saying host 0 is the LSI controller, and the driver then sends port enable and port enable success, and everything's added. So this is important to know that this is host 0. If you have multiple controllers, then that number will increase as it enumerates additional controllers. So the next one, if there was a second controller, would be host 1, host 2, host 3, and so on and so forth. SAS technology is not the only way to provide storage. So actually over here, you'll notice a whole bunch of other ones. So SCSI host 1 HCI, host 2 HCI. So HCI is basically the SATA controllers. These are probably the SATA ports on the motherboard, basically. And then we have HCI EM, which is, I believe, enclosure management. So there's some sort of perhaps SATA enclosure. I'm not exactly sure, but that's kind of what I would guess, not actually seeing any of the hardware. Like I said, I don't know this person's hardware. I have not seen the actual physical hardware. I don't know what they have installed in here, but basically just judging from what I'm seeing in the logs messages here, it looks like they have some sort of enclosure device. And so you'll see here host 7. Okay, so this number after the host is important to keep in mind if you're trying to trace down things. You'll see down here SCSI target 7000 enclosure. All right, so host 7 is basically this SCSI target 7000, and indeed it says it's an enclosure. It's a HCI enclosure that has SGPIO, blah blah blah. I don't know what that is. We're interested in the LSI controller, so we're looking at host 0. And so let me scroll down a little bit here. So you start seeing all these messages. Here, let me highlight this at the SCSI layer that starts with 0. And so these are all host 0 events, activity that's happening on host 0, which is that LSI controller. And so you'll see that we are seeing some drives being connected. So basically, And so I'm just highlighting all the target 000. So it's an ATA, so it's a SATA drive. WDC Western Digital, some sort. Here's the, I think that is a serial number probably of that drive. And yep, we see that it's a SATA drive. There's a SAS address. I don't know if that's, I think that's the, yeah, so I think that's probably SAS address of, is that the device? Maybe the device itself. But this is, so what's interesting is that this is actually, it looks like it's connected through a SAS expander. All right, so it's on 5.3, so, you know, basically that tells you the port that it's on and stuff like that. But you'll notice right here, all right, so enclosure logical ID slot 0, right? So this is telling us that this drive is connected to that host 0 LSI controller through an enclosure, which is a SAS expander, basically. All right, and then a bunch of features that are either enabled or disabled. So, you know, we got, does it support a tapping? No. Does it support NCQ? Yes. Asynchronous notify, smart? Yes. This is basically like direct access to the drive. Yes. And I don't know what SW_preserve means, but anyways, this is basically just a, you know, identifying what features are supported or not supported. All right, so basically we're seeing at the SCSI layer that there's an enclosure device connected to this LSI controller, and this particular drive in slot 0 is being detected, and that kind of stuff. And so we're going to see repeats of that happening here. This is now on slot 2, again going through the enclosure, another drive. So okay, that looks like it's a model number, not because it's the same here. So that's just the model number, not the serial number. But anyway, so it's another Western Digital drive. We basically see a repeat of this. So we have multiple Western Digital drives being connected and coming online, and all of them are going through a enclosure. They're all connected to a SAS expander of some sort. So this is slot 0 of the SAS expander, slot 1, slot 2, we got slot 6, slot 5, slot 4. All right, so all these drives, that looks like 6 of them. 1, 2, 3, 4, 5, 6. Yep, 6 Western Digital drives are connected through a SAS expander in this case. All right, so let me scroll down just a little bit more. So earlier, remember we saw the other hosts on the system. Let me go back here. Okay, so I just scrolled back up. You'll see that all these hosts 1, 2, 3, 4, 5, and 6 are AHCI, so those are probably the SATA ports, and we'll see that down here as well. So let me scroll back down. Oops. All right, here we are. So we see SCSI target 3000, 4000, and so those are those trace back to host 3 and host 4, which are HCI, which are SATA, and we see some Samsung SSDs here. All right, so far so good. The kind of SCSI layer initialization detection of the drives through the LSI controller seems to be successful, and no problems so far. All right, so this is telling us that basically the operating system can see the hardware, the drive, the storage hardware, and the controller. And now we're going up one more layer to the block device layer. And so lots of messages here. And we'll see that target 0010 here at the very top of the highlighted lines. Again, this first number pertains to the SCSI, number that we saw earlier. So 0 is host 0. So this is from the LSI controller. And this 1 is basically the slot 2 from that enclosure and stuff like that. So this drive that we saw earlier that was detected at the SCSI layer is now being assigned a block device name called SDA. And it tells us how many blocks are detected of what type of logical block size. And so it comes out to roughly a 16 terabyte drive. And it's telling us also So we're seeing multiple things coming online, and so they're not exactly going to be in order. But if you want to kind of follow this, you would want to stick to all the 0010s. So for following this, then we have 0010 is showing as a 4K drive basically, but it's probably 4K or 512E as my guess. So it natively has 4K blocks, but it's presenting as a 512 byte block, so it's probably emulated, is my guess. All right, so that's 0010, and we'll see very similar things with all the other drives. So the 0020, 0030, all very similar. And here we have device 3000. So that's the Samsung SSD that we saw up here. So what I'm trying to show you guys here is how to follow the messages to kind of connect the dots between the different layers of the storage subsystem. So, you know, from host 0 or host 1 being the SATA ports or whatever, we've connected the dots to the SCSI subsystem. Now we're connecting the dots to the block device subsystem. So everything here looks good, right? This is basically all those drives attaching SCSI disks, attached SCSI disks. So, you know, everything's getting connected to the operating system, and each drive is being assigned a drive letter, and everything's all nice and neat. And then we have SES, and so that is the SAS enclosure subsystem, I believe is what that stands for. And that is 7000. This is being assigned a SCSI generic device name as SG0. So this is how you would communicate with that enclosure. And if you've seen my video on how to low-level format SAS devices or how to flash the firmware on SAS expanders, you'll recall that this is how you would address those devices using the SCSI generic interface. And so this is just messages showing you that those SCSI generic interfaces are now being assigned to each of those devices, so that, you know, if you needed to communicate with that device at that low level, this is the name that you would use to communicate with it. All right, so on August 5th, basically it looks like everything initialized and started up just fine. And then 6 days later, we start seeing some problems. All right, so on August 11th, we start seeing problems on ST0010, and we're starting to see command timeouts happening, right? And you'll see that it's happening through the enclosure on slot 2. And so we see more of this on 0010 target. Same thing. These are a bunch of basically read. Oh, well, there's some writes as well. So we have read-write failures on target 0010. And again, this is all going through a enclosure device. All right, so we're seeing a lot of failures on drive SDA, which is the 0010. So that was at 21 hours and 22 minutes. It looks at about an hour later, at 22 hours and 20 minutes, we're starting to see similar problems showing up on drive target 0040, and this is drive SDE. So we're starting to see this problem hop to another device. And so we see a lot of that on this drive SDE happening, okay, at 22 hours and 20 minutes. And then at 22 hours, 24 minutes, so about 4 minutes later, we're now seeing the problem on target 0020. So very similar type of behavior that's basically happening across the board. Okay, so we're seeing, again, same thing happening now back on drive SDA. And so this problem is just basically hopping around, going from drive to drive, drive to drive, right? And you'll notice that this is all on host 0, right? All these devices start with 0. So we're talking about just the LSI controller, the devices that are connected to that LSI controller connected through that SAS expander. All right, so this is just more of the same stuff. We're not seeing anything on, you know, host 1, 2, 3, 4, 5, and 6, which are the SATA ports. So there's no problems with SATA ports. We're seeing problems only on devices that are connected through the LSI controller. It's again hopping around from SDA, SDA again, SDA, SDB. All right, so there's more and more of this stuff. I'm just gonna scroll through this a little bit faster now. Basically, we're seeing the same pattern, repeating itself. So we're just gonna. All right, so that's the end of it. So okay, what can we conclude from this? Let me pull up a diagram to kind of map out what we've seen, and explain to you how to kind of analyze what we just saw and translate that into how to isolate what the problem is. So give me 1 second. I'm gonna put together a little diagram. All right, guys. So here's a just really quick and dirty diagram of a LSI HBA controller connected to a SAS expander in the middle here. And I don't know exactly how many cables were used to connect that SAS, the HBA to the SAS expander, but I know that at least with one cable you're going to have at the very least 4 SAS lanes. So I have 4 lines here to represent those 4 SAS lanes. It could be 2 cables and you have 8 SAS lanes in total. All right, and from the SAS expander, the individual drives, there were 6 of them that we identified, and they were all SATA drives, are connected to that SAS expander. Now I don't know if that SAS expander is part of a backplane or if it was just kind of a standalone SAS expander card and there were breakout cables from that SAS expander to those drives. Like I said, I did not get to see the actual hardware itself, but just based on the analysis of the logs, this is kind of a rough idea of what the setup looks like. All right, so going back to what we saw just earlier in the log files, we didn't really see any error messages coming from the driver. So that's the MPT2 SAS here. And so my guess is that this is not a problem with the controller itself. And so I would probably eliminate the HBA as a problem because we didn't see the driver resetting the controller and any other kind of driver level error messages. We are seeing a lot of read-write timeouts with the SATA drives, and so one might be inclined to say, well, maybe something's wrong with the drives. However, we're seeing those problems hop around from one drive to another. And I also asked this individual who I was trying to help that sent me those log files, log messages, to look at these individual drives and check their smart attributes. So one thing that I always like to look at when we're having problems like this is to look at attribute, if they're SATA drives, look at attribute 199, I believe, which is the UDMA CRC counter. That is a counter that tells you whether there's been some transmission noise, some error correction had to happen in order to kind of keep the integrity of the signal. And so if you see a lot of CRC failures, that usually means that there's some noise, there's some transmission error happening between the drive and whatever that drive is connected to. In this case, it would be connected to the SAS expander. And it turns out, and I don't have that information to show you, but it turns out that basically there were no UDMA CRC counts. So that means that there's no communication problem happening between the SAS expander and the SATA drives, and yet we're still seeing all those errors that we saw earlier, right? So, but because of that, I would probably eliminate the possibility that the drives are the problem, okay? And there's a couple of different facts that kind of tell me that, right? Like one, that the problem is hopping around various drives, and so it's not very likely that all drives are failing at the same time. Now there is one other possibility that we're not talking about here, and that is the power supply to all those drives. So if they're being supplied power from the same rail from whatever power supply system this person's using, and that rail was a little bit flaky, it's possible that you could have simultaneous problems on all these drives because they're being supplied from the same power rail that's having problems. But I don't really think that's usually it doesn't usually manifest in that way. Like usually if you have a power problem, then the drives don't power on or they power on. So it's kind of typically very binary. You're not going to kind of get this intermittent thing with a power supply issue usually. Okay, but that is one possibility that could explain why the problem seems to be manifesting across all these drives. All right, but anyway, because I did ask the individual to take a look at the attribute 199 UDMA CRC counters, and there were none. And so I don't suspect a connection problem with these drives. And then the drive health itself, these drives were tested, I believe, or at least the person told me that they had tested these drives, and they didn't exhibit any other problems in another system connected directly through a SATA controller or something like that. So I would eliminate the SATA drives as being the problem, and I would also probably eliminate the connectivity between the SATA drives and the SAS expander being a problem. So these lines over here, and that's just because we're not seeing any UDMA CRC errors on the drives. If we did, then that would probably be my prime suspect, is that we have a cable problem somewhere between the SAS expander and the drives. In this case, maybe we have multiple cable problems because there's 6 drives. That means even if you had a breakout cable, you need at least 2 cables to connect 6 drives, right? Based on that information, I've eliminated the HBA controller, I've eliminated the drives, I've eliminated the connectivity from the drives and the SAS expander. So this narrows down our scope of where the problem might be to the SAS expander or the connectivity between the HBA and the SAS expander. All right, so we've kind of narrowed it quite a bit here so far. Now another hint, and I don't really know exactly what the problem is. This problem is still, I provided some of my guidance to the person who's having this problem, and I didn't hear back from them yet. So I'm not exactly sure if they ever were able to identify exactly what the problem is and what it was. I did tell them that I think the problem is somewhere between the SAS cables connecting the HBA to the SAS expander, or possibly the SAS expander itself. Now, SAS expander failures, I have not encountered many of them. I have seen some bad SAS expanders, so like a SAS expander that was kind of having problems out of the box, not one that was working and then started failing. In those cases, they were kind of binary. They either worked or they didn't work. The fact that we're seeing this start up, again, like was it August 5th, everything starts up fine, everything looks good, and then a couple of days later, we start seeing errors. Or like 6-7 days later, we start seeing errors, right? I don't typically see SAS expander failures that are kind of intermittent like that. It's usually fairly binary, where it's either works or doesn't work. Now, if we go back and look at the logs here, you'll notice that the problem kind of hops around, right? Like you'll see a bunch of messages about target 0000, then it's target 0010, right? So that is another hint that kind of points the finger at this SAS cable here. Okay, and here's why. So this SAS cable carries multiple lanes that are connecting the HBA to the SAS expander. When communication is happening across this cable, okay, the HBA and the SAS expander basically try to load balance that communication across these 4 lines. And again, there could be more than 4. Perhaps this person's using 2 cables, and so there might be 8 SAS lanes between the HBA and the SAS expander. But either way, we have multiple SAS lanes between the HBA and SAS expander. Now, if one of these lanes is bad, then you might have perfectly fine transmission going back and forth so long as the communication is going over the good lanes. But again, because the communication is being load balanced, basically kind of goes round robin across these lines. So the first communication might go across the first line, the second one might go to the next line, and the third one go to the third line, and so forth, and kind of keep going around, alternating which SAS lane to use for that particular instance of communication. So if there was one particularly bad SAS lane, or maybe 2, until the communication actually ends up crossing that bad cable, you don't notice the problem. And so this could explain why during the initialization and startup, there's not a whole lot of I/O going on necessarily. It's just kind of initialization, handshake kind of stuff. So it might be you just going over one SAS lane just to do the handshake and say, oh, there's a drive, it's 16 terabytes, great, hallelujah, and everything looks fine because you're going over just the good SAS lanes. But then once there's I/O going on, where there's more communication going on, and the controller needs to then start distributing that I/O across multiple SAS lanes, you might start hitting one of the bad SAS lanes if our hypothesis that one of these SAS lanes might be bad is true. And so that would manifest as whatever particular drive the controller was trying to communicate to at that time. When it hits that bad SAS lane, the problem will look like that drive is having problems. And then it goes on to the next SAS lane, which might be good, and then everything seems to be fine again. And then the next time it hits that bad SAS lane, it might be attempting to communicate with a different drive, and so then we might see the problem manifest on a different drive. And that's kind of exactly what we're seeing here, is that the problem seems to be hopping around. And so I suspect, if I based on the log information and kind of just correlating that to what we're seeing, my best guess is that this SAS cable between the HBA and the SAS expander has a bad SAS lane. That would be my number one suspect. Now, before just throwing the cable out, I would also try to reseat the cable. So this is also a very common problem that I see. If you've watched my video, the 13 reasons why your drives aren't showing up or why you might be having problems, like I said in that video, 70% of the time people have problems, it's because they didn't plug the cable correctly all the way in. And so I would at least attempt that, reseat the cables on both ends, on both the HBA side and the SAS expander side, and see if this problem goes away. If it doesn't go away, then I would replace that cable. So that would be my first suspect, is to try to eliminate the most likely cause that could explain the behavior we're seeing in these log messages. Anyway, that's it, guys. Hopefully this helps you guys out when you are troubleshooting Linux-based systems with a LSI controller. And just to kind of give you an example, a real world example of me trying to troubleshoot and analyze the logs and trying to use some logic to eliminate the possibilities of where the problem might be, and then trying to show you guys how the behavior of the errors can help indicate what might be the most likely cause of the problem here. And so anyway, just wanted to share that with you guys. Hopefully it helps you guys out if you're ever trying to troubleshoot a problem similar to this. All right, guys, so that's it for this video. If you like this video, be sure to give me that thumbs up. And if you're new to this channel and you like this sort of stuff, consider subscribing to my channel and hit that notification bell so you don't miss my next video. Also, if you want to support my channel, go check out my eBay store. I've got the best selection of pre-flash IT mode HBA controllers. I'll leave a link down in the video description. Go check that out if you want to support my store. Have a good day, guys. Bye-bye.